Hello again. This video is really kind of one of my more favorite ones. It's where geometry and algebra kind of intersect. So we're going to be dealing with some algebraic equations, but they're basically formulas from geometry. Okay, which is why this is on my geometry site rather than the algebra site. But it's basically some algebra, but with formulas from geometry. So let's ooh, that's not good. Let's see. Here we go. So as a function of, this is the title here, and what we're basically trying to do is write a multivariable formula with just a single variable. Okay, like think for example the area of a triangle formula. The area of a triangle is a function of, or rather is determined by the base length and the height of the triangle. So as an example, area for a triangle equals 1/2 of the base times the height. Okay, so the area formula is a function of, right, will change as the base of the triangle changes or the height of the triangle changes. So here is an example where the area is a function of two different variables. Okay, or if we're talking about a circle, the area of a circle is just pi r squared. So a circle formula, or a circle is an area, or rather the area for a circle is a function of radius. Okay, as we have different radii or different lengths of the radius, the area is going to change. So area of a circle is a function of radius. So that's what we're talking about when we say as a function of. That means as this thing changes, so does the area, or so does whatever this happens to be, volume maybe, or whatever. Okay, so like in there, we have two variables, and we want to actually express as just a base or a height without the other one in there. Okay, and this will make more sense when we start doing some examples. But we do that by finding a relationship between the variables within that formula. How does the base relate to the height? Okay, and we can use substitution to replace one with the other. So here are some examples. We're told that the perimeter of a rectangle is 40 inches, and we want to express the area of the rectangle as a function of its width. Okay, so if we start with our two formulas, area for a rectangle, that's length times width. Okay, so area is a function of length and width right now. We don't want it to have length in our equation, we only want to have W. So somehow we want to get rid of this length. Okay, and the only way we can get rid of something in algebra is with substitution. So we're going to replace L with something. Substitution. Okay, so we're going to replace L with something. That's the only way we can actually get rid of it. So here we have an area formula. The other one is a perimeter formula. So we know two things about this triangle. We know that the perimeter is 40, and there's an equation for perimeter. Okay, the perimeter of any rectangle is found by 2 lengths plus 2 widths. Okay, so if this is our rectangle, this is the length, this is the width, this is the length, this is the width. Perimeter is the sum of all the sides, so L plus W plus L plus W is 2 L's plus 2 W's. Okay, so here's where the awesomeness comes in. If we want to get rid of L over here in our area formula, that means we're going to have to solve for L over here in your perimeter formula. Okay, because if we can down here magically have L equals something, right, we have solved this equation for L, and now that we know that L equals something, we can then substitute it back into here. Okay, and that's exactly what we want to do, is use this substitution so we no longer have L, but we have some other type of equation with W in it. Okay, so let's go ahead and solve this equation for L. The first thing we're going to do is subtract 2W from both sides. Okay, and that gives us 40 minus 2W is 2 lengths. Okay, now I got to get rid of this 2, so I'm going to divide everything by 2. Every part gets divided by 2. And I figure out that my length is 20 minus whatever the width happens to be. Okay, so with that, let's make a little table here just for fun of lengths and widths. So if I had a length of 5, then the width is going to be 20 minus 5, or 15. Okay, very easy to calculate once we know this. If I had a length of 2, the width would be 20 minus 2, or 18. Okay, because the perimeter can't be anything other than 40. So 2 plus 18 plus 2 plus 18, well, that adds up to 40. 5 plus 15 plus 5 plus 15, that adds up to 40. So the length is 20 minus whatever the width happens to be. I guess we should say width and then length and subtract it. Sorry, that was all backwards. So now back to our algebra. Instead of having an L, we're going to put instead 20 minus W. Okay, that's what we figured out our length was. So we substitute 20 minus W into here. And now when I finish by distributing, I get a single area equation with just W as my variable. And that's exactly what I want to do when I'm writing an equation as a function of a single variable. It starts off with a 2-variable formula and it ends up with a 1-variable formula. Okay, so that's the gist, that's the idea. We have 2 equations. We have an area formula and a perimeter formula. Get rid of one letter by solving over here and then replacing. Okay, maybe another example would be good. So here are some more examples. We want to express the area of a square in terms of its perimeter. Okay, so we have 2 equations once again that we're dealing with. Here's our square, 90-degree angle, all congruent. All 90. So we have an area formula. Area equals x squared. So if I'm going to call the side of my square x, because I don't know what its length is, then the area is going to be x squared. Okay, the perimeter is x plus x plus x plus x, which is 4x. So right now, area of a square is a function of side length. Okay, so normally the area of a square is a function of its side length. If you knew the side length, you could quickly solve and figure out what the area of the square is. Okay, but we don't want to have to do that. We want area of a square in terms of its perimeter. Okay, so if I gave you a perimeter, say the perimeter of this thing is 40, you can go directly into figuring out what the area is rather than first finding out what the side length is and then doing it. Okay, it's supposed to save a step, but it's actually an algebraic exercise. So if we want to get rid of x in this equation, that means we want to solve for x over here. Okay, so get rid of x in our area equation. That means we have to solve for x over here. Okay, so that's not hard to do. 4 times x, we divide both sides by 4. We figure out that x is the perimeter divided by 4. Okay, because we can't get rid of something unless we substitute it. So now I have over here, let's make this a little bit thicker. The area is the side length squared. Okay, and we determined that rather than having x, we were going to put in here p over 4. Okay, the side length is the perimeter divided by 4, and that's what we got from right here. So we are substituting that value in here for x. And now with a little bit of simplification, I'm going to square the p, I'm going to square my 4. So area is p squared divided by 16. Okay, so now if I gave you the area, or rather the perimeter of a square, you can directly calculate the area using this formula. Okay, sometimes that's handy, sometimes it's not, but it's a great exercise in algebra. Okay, with some geometric formulas. I think I have 3 more. Let's do some more. Express the area of a circle as a function of its circumference. So like we said before, area of a circle is a function of its radius. Okay, that's the only variable in this formula. So as the radius changes, the area will change. So area is a function of radius. Circumference, on the other hand, is also a function of radius. So notice both of these things have the same variable in common. Okay, which makes it very nice. So I can get rid of it here So I can eliminate my r. I don't want area as a function of radius. I want area as a function of circumference. So if I'm going to get rid of the r over there, I'm going to solve for the r over here. Okay, so solving for r, I divide both sides by 2 pi. So my radius is the circumference divided by 2 pi. Okay, so back over here, I'm going to come and I'm going to replace r, my radius, with c divided by 2 pi instead. Okay, so now I have area as a function of circumference, and I simply need to simplify. So I'm going to distribute my 2, I'm going to square the c value, I'm going to square the 2, I'm going to square the pi. Okay, everything gets squared when you distribute. So that's pi times c squared over 4 pi squared. And now I multiply. Pi times c squared is, of course, just pi c squared over 4 pi squared. Okay, now notice we have a pi on top and 2 pi's on bottom. So algebraically speaking, one of these will divide out the other one. And they can be essentially eliminated or divided out. So the area is the circumference squared divided by 4 pi. Okay, that is area as a function of circumference, not as a function of radius like it normally is. So notice the only variable in our equation or our formula is c. 4 is a constant, pi is a constant, squaring. C is your only variable. So as a function of c circumference. Okay, I believe our last, let me see what the next one is. No, 2 more. So express the perimeter of a square now as a function of its area. So remember from before, perimeter of a square is 4 times x, where x is the side length. Let's put that back in here. You can use whatever variable you want to for the side length. Sometimes you use s. My s's look a lot like 5s, so I try to stay away from s's as a variable. So x is good. Perimeter is 4x's, area is, of course, x squared. So if I want a perimeter formula, that means I'm going to have to get rid of this. Okay, I want p equals in the end. So over here, I have to solve for it. So get rid of here means we solve in our other equation. Okay, so how do we solve a square? You solve a square by square rooting both sides. So the side length of a square is found by taking the square root of the area. Okay, I should have done that in a new color. Anyway, back over to here. So perimeter is 4, no longer times x, but rather times the square root of the area. So I'm replacing x, I'm substituting this. Okay, there's not much we can do here to simplify except for take away the parentheses and take 4 times the square root of the area. Okay, perimeter as a function of area rather than perimeter as a function of side length. Okay, our last one, express the area of a square as a function of its diagonal. Okay, so this one's a little bit different. So area is still x squared. So let's talk about the diagonal of a square and how we can figure it out. Okay, so this is the diagonal. The diagonal goes from one corner to the other corner. Okay, and hopefully as you remember, a square has a 90-degree angle in it. So in essence, what I'm trying to do is find the area of this, or rather find the hypotenuse of this right triangle. Okay, so the diagonal of a square becomes the hypotenuse of a right triangle. So let's see, go back here. This is going to be called D, where my side length is x. So because this is a right triangle, I can use Pythagoras to find the hypotenuse. So x squared plus x squared equals d squared. Okay, remember, I'm trying to solve this for d. So this is my other equation. I have an area equation, and then I have a Pythagorean relationship. Okay, so Pythagorean relationship. Okay, so I don't have a secondary equation for diagonal. I have this Pythagoras x squared plus x squared equals d squared. So 2x squared equals d squared. And when I take the square root of both sides, I can, well, why don't I just leave it like this for a second? The square root of 2x squared is the diagonal. Okay, now this might be a little bit better for me in the long run. So because I want to get rid of x, whoa, that means I did something completely wrong, didn't I? Yes, thank you for catching that. Let's go back and do this right. So this is true. Let's go back here. If I want to get rid of x over here, that means I have to solve for x over here, doesn't it? Yes, it does. All right, let's go back. So x and x, well, that was still 2x squared equals d squared. But now I want to divide both sides by 2. So x squared equals d squared over 2. And now when I square root, x is the square root of the diagonal squared divided by 2. Okay, this is what I want. I want to solve this Pythagorean equation for x. Area as a function of diagonal. So this something squared is what I'm going to find out now. Okay, and of course, x turned out to be diagonal squared over 2. And algebraically speaking, when I square a square root, okay, those are inverse operations, so they cancel each other out, or they undo each other. So the area turns out to be the square of the diagonal divided by 2. Look at that. Area as a function of diagonal. Okay, so hopefully this was helpful as a function of these geometric relationships that turn into nice algebraic problems.